Welcome to Object Relationships. So by the end of this lesson, I hope that each and every one of you will be able to model one-to-many relationships and code one-to-many relationships. So let's talk a little bit about what one-to-many relationships are all about. Go over here. So when we talk about a one-to-many relationship, we're talking about ownership. What owns what belongs to what. So broadly speaking, when we have one of these relationships, we're saying that I can have many of these things and each individual one of them is owned by me. And it turns out that there's a whole gaggle of things that we can describe that way. So I might say, I have this desk right now, and I could say my desk has a water bottle. Can my water bottle be on any other desk at the same time? No, it cannot. So we could say that this desk has many items or something like that. Each one of them belongs to my desk. I might have a bunch of icons on my computer desktop. So we could say that my computer desktop has many icons on it. Each icon is only on my desktop, not on your desktop, not in some other folder. That's specifically where it is. So we represent this idea like this. We say that this is the one side. Sometimes you'll also see a little thing here that helps. One of these has many of these. Each of these is owned by exactly one of these. That's a one-to-many relationship, also called a 1:M. Ask me some questions about this idea.
It's basically just if an owner can have many dogs, but just the dog has that one owner.
Exactly. That would be a one-to-many relationship.
Like animals have fur and many things have fur, but mostly no.
Ooh, you're getting into dangerous territory because you're starting to scratch at many-to-many relationships. We'll talk about those in a minute.
So can either the one or the many access each other's variables and methods?
Absolutely, if you set them up that way. But like at this level of modeling, yeah, these two things can talk to each other.
Okay. Both ways, you're saying?
Correct.
Thanks.
I know who I own, and all the things that are owned by me know that they're owned by me.
Cool.
Does that work in comparison to like classes, or is it more specific to individual parts of the class? Like, can one class have many other classes, or is it more like more nested in the data than just the class itself?
So it's a really interesting question because this doesn't actually have anything to do with programming. This is like broadly called data modeling, and you could do this with filing cabinets. You can do this with objects and classes. You can do this with database tables. You can do this with all kinds of stuff. All we're talking about is like nouns and how they relate to each other.
Okay.
But to like more directly answer your question, it's talking about objects and the relationships that objects have with each other.
Okay.
Other questions thus far? Cool. Cool. We're not going to spend a whole bunch of time on them today, but I do want to show you the two other really common kinds of relationships so that we can contrast the one-to-many with them. One of them is one-to-one. The big difference here is this is. This is this. So I am an employee and I'm a manager. I'm a person. I'm also a pilot. Two different angles on the exact same thing. They're pretty rare. Well, not like they're reasonably rare. It would not surprise me if you go through the rest of Flatiron without doing a one-to-one relationship. Some are also represented as self-joins. So like if this was an employee, we go, cool, employee, who's your manager? Another employee. It's also a one-to-one relationship. And the other one, we do see a ton of, but we're not ready to talk about just yet, is many-to-many relationships. This is one of these owns a bunch of these, and one of these owns a bunch of these. So Christopher, in your like dogs and fur example, you go like, all right, fuck, how would that be? This thing has fur, but so like dogs have fur, but fur also, like many other things also have fur. Probably be something kind of like that. We can take a lot of the same relationships and represent them either as one-to-one or one-to-many or many-to-many. So the dog's example is a good one. We could say that every dog is owned by exactly one person. Or you could say that I can have many dogs. Each dog can also have many owners. There's no hard and fast rules. It has to do with how your application works. Does your application allow for a dog to be owned by more than one person? Then you should model it that way. That could be, I'm looking at my shoes right now. So I have a bunch of pairs of shoes. Each pair of shoes is owned by only me. If I had like slippers or something like that, that maybe like my kids use or my wife uses, then it turns into I own all these slippers and some of them are also owned by my kids or my spouse. And maybe they each have records for that. That's a many-to-many relationship. Okay, so I'm gonna have you try to come up with some one-to-many relationships. In my experience, mixing these two things up is probably the most common thing when you're getting started. So before we do that, I want you to ask me some questions. Tell me things that you think might be one-to-many relationships. Ask me some more questions about many-to-manys. Let's get a little, let's get one notch more comfortable with this idea.
Like, go
after
ahead,
you-
Chris.
After you, Cassie.
Like mammals
Mhm.
and a list of animals that are mammals. Like that's one to many. Or
I would, so like, let's say you have like type of animal. And you could say that this is an animal. This is a one-to-many if every animal has only one type. If it can be a mammal, but not an amphibian and not a bird, if it can only be one thing, then you'd say that one of these has many of these. Now, if something can be more than one of these types, then it's a many-to-many.
okay.
Great one. Christopher, what you got?
Well, I was going to say the example you gave of a person owning many shoes.
Yeah.
but nobody else is going to wear those shoes.
Right.
That's a great like concept there. I'm going to kind of lock that in.
Nice.
You know,
Or we could also do that one as a many-to-many if, for example, I have Kyle, or a person, and we've got shoe. So this is Kyle. This is Nike Airs. You could say that a whole bunch of people have Nike Airs, and there's a whole bunch of people. And so then all of my specific Nike Airs, maybe I keep track of those.
Okay.
But, well, and we'll talk about this more next week. When you actually implement that, that looks like person has many, like, personal shoes.
Okay.
And then a shoe has many personal shoes.
there's
Like, this is a many-to-many relationship. Many-to-many relationships end up breaking down into two one-to-many relationships, always. But one other thing that like, trips people up about many-to-manys was say many-to-many. It's written like that.
M to N?
M to N.
M to N.
Because it's a math thing. They're like variables. We're saying that they're not literally the same thing. M to M would be like a self-join.
So you said many-to-manys always break down into one-to-ones?
One-to-manys.
One-to-manys.
This always ends up turning into this.
Because you have to have a way to link them together.
Exactly. This is the link.
Yep. Would another example be the planet has lots of people?
Mm-hmm. Every person's only on one planet. Love it. So
Well, astronauts excluded, right?
yes. Well, like even then, you could say you can't be on Earth and Mars at the same time.
How about the International Space Station, though?
Well, like so, let's say you're making an app, something like that comes up. You got to change your data model because now it's not just planets. Now it's like places, of which planets are one. So you can say, yeah, planet has many people. Each person is only on one planet at a time. Same thing with that, like every dog is owned only by me. Okay, what if I sell my dog? The point is it's not owned by both of us at the same time. Other questions about one-to-manys?
I guess my super big and generic question when we're now relating this into programming is simply why?
Sure.
What's next?
Think back to Tuesday when I was showing you like my dog and owners app. I want to go, cool, who are all of Kyle's dogs? Who owns Bixby? Those are questions you ask in applications all the fucking time. Like, let's go over to GitHub. Been spending a lot of time there today. If I go, all right, so here's my profile. That's probably some kind of object. And then I've got all these repos. So like if I'm making GitHub, then I probably have to say something like, all right, is every repo exclusively owned by only one person? Or can more than one person own a repo? Is that one-to-many or is that many-to-many? I go, cool, I'm part of all these organizations down here. Do those organizations belong to me? Can they have many people in them? Can I be in more than one organization? So I can be in more than one organization, and each organization can have more than one person in it. So that's a many-to-many relationship. Things like this, the city that I'm in, my email address, my website, those things are just attributes of me. But I have all these other things that are their own distinct objects. You got to say how that relationship works. That's how this relates to programming. Other questions?
I'm still kind of confused on the one-to-ones, like why that's not a one-to-many, I guess.
So like in this case, employees and managers,
Yeah.
your manager is also an employee.
Or like self-employed?
Yeah, well, like that's like, yeah, I guess that could work. Because like in practice, that would look like this. So this is my employee model. An employee has an ID, and they have a name, and then they have a manager ID. So if we're doing a one-to-many kind of thing, then this manager ID would be in like a manager's table. Okay, but a manager is just an employee. Those are the same kind of thing because your manager also has a manager. So what do they relate to? So this ends up being like that. It's kind of abstract, and like I said, I would be shocked if you actually use one during the program.
Okay, I kind of get like one-to-one. You can have two statuses, you know, but you can't have a dog. Well, I guess you can have a dog and be a dog at the same time, but that's, you know, a weird situation. But my confusion is where you said many to minis have that link of one to many, because I was thinking like, okay, people into shoes, then it would be like a person has like a pair of shoes, and then the shoes are that link that go to shoes. But you said it more like there'd have to be like multiple shoes in the middle there, or that's kind of what confused me.
Yeah, so like let's take this the Kyle and Nike Airs thing. Let's add some more people. So there's Elise. There is Reebok, something or others. And so then what happens in the middle here is going to be every coincidence of these two things. So this is Kyle's Nike Airs.
Okay, so shoe is the type of shoes.
Yes,
That's the
exactly.
Okay, it's not the physical pair of shoes. Okay.
Correct.
The physical is the middle. That makes sense. Okay.
Yep. So yeah, that thing in the middle is keeping track of every place where these two things collide.
Mm-hmm.
And so if I want to find out who has Reeboks, this is the model that I'm looking at.
Gotcha.
Other questions about one-to-manys, many-to-manys, difference between them? All right. So what I'd like you to do now is I want you to send me a Slack DM with 3 examples you can think of one-to-many relationships. Use your imagination, look around your room, think about software you've used. What are things that have this relationship with each other? Slack DM me 3 things. Go. We'll give you 3 minutes. Okay, I need a couple more. All right, cool. Let's talk about some of these. All right, so first one. One student can take many lessons. That's a good one. Let's talk about it. So we would write that as student lesson. And as described, saying one student can take many lesson, but each lesson is only taken by one student. Is that right?
No.
What should it be?
Unless it's a private lesson.
Sure. Oh, yeah, private lesson. I'd buy that.
That's what I was thinking too when I made mine. Kind of added a little more like details or specificity to the to the mini thing. Like I have mini watches, but they're male buckle adult size. So my daughter wouldn't wear it, and my wife wouldn't want to wear it. So I have multiple watches that are just for me.
Yeah, I like it. I would say this is true. Every private lesson has exactly one student, but a group lesson would be many to many. That's true.
Mm-hmm.
But with the group lesson, only has that one single student.
So, say that again?
So as a student could be in the group lesson, but I mean, the group lesson can have many students, but it only has one of that student. I guess you're just characterizing it as just like a general student.
We're talking about the shape of the relationship.
Right.
So like a group lesson might only have literally one student in it, but it could have more. That's what makes the relationship a many to many. And you could say that this student is in this group lesson, and this group lesson has more than one student, ergo, many to many relationship.
So you got to kind of think of these going both ways.
Yes, exactly. Here's another one. One waiter can serve many tables. We'll say waiter, table. One waiter serves many tables, but every table is served by only one waiter. Yeah, could be. You might also have a restaurant where like, there's teams of waiters. So these 3 people are waiting this table right now. Depends on how your app works. But yeah, this is totally plausible. Let's see. A hive of bees has one queen. So let's say like hive, queen. So we'd say that, oh, this is an interesting one. So one hive has one queen, and one queen has one hive. What's that?
1 to 1.
1 to 1. Hive is the queen. Queen is the hive.
But if it were bees,
There we go. If
then
I
that would be one to many.
bees, what is it?
1 to many.
1 to many. Each hive has a bunch of bees. Every bee is in only one hive. Very nice. Fridge to food. Now this one this one gets a little bit complicated. Kind of depends on what we mean by fridge and what we mean by food. So if an example of a fridge is Kyle's fridge and Chris's fridge, and if what we mean by food is something like this bag of chips. So we're not saying Fritos, we're saying this bag of Fritos. I guess that doesn't go in a fridge. This, whatever, we were talking about Canadians earlier, this bag of milk. Not any bag of milk. If this is referring to a particular bag of milk, then yeah, that can't be in Kyle's fridge and Chris's fridge at the same time. So we could say that a bunch of things could be in that fridge, but each one of them is only in one fridge. By that. Mother to children. Mother can have many children. Each child only has one mother. That's one to many. Boxable baseball cards. What was that?
Can we go back to the student example really quickly?
Yeah.
Because my question is, I know if we say like students, then that makes sense to me that it's a many to many. But if I specify it and say Kyle to group lesson, is that a one to many, right? That or is that still
what the shape is? Because
the shape?
for every one of these, we call them entities in data modeling. This is kind of like a class. It's a blueprint.
Yeah.
Kyle isn't a blueprint. What is Kyle in your app? Kyle's a person.
Yeah,
Kyle's a student. Kyle's an instructor. Kyle's an employee. So you're looking at the shape of what that example is.
Okay. Okay.
And like the pluralization thing on this, you'll see this both ways. As somebody with a degree in data modeling, singular is correct, but it's a little bit of a holy war thing. And the Ruby world decided a long time ago that it wanted to pluralize these. And so this would be students to lessons instead of student to lesson. It's the exact same thing. It's a semantic.
Okay. That's cool.
Let's talk one more. Boxable baseball cards. Baseball card and box. So you might say that one box has many baseball cards. Each baseball card is only in one box. And that kind of runs into the same thing as food. There's a lot of Ken Griffey Jr. rookie cards. My Ken Griffey Jr. rookie card is in this box. So it just depends on which way you're talking about it. Ah, fuck. I thought I had a Ken Griffey Jr. rookie card like right over there. Couldn't find it. That was gonna be pretty fucking dope though.
Come back as Ken Griffey Jr. Maybe like a onesie.
Cool. Ask me more questions about one in many relationships now that we've talked about this a little more.
Can you give like a good example? I guess like the server tables one was good, but like one that doesn't exactly just mean like ownership, like.
Sure. I could maybe say, somebody brought up reviews. That's an interesting one. So I could have person and review. What's the relationship there?
One to many.
One to many. Okay. A person can write a bunch of reviews. Every review is written by exactly one person.
Okay.
Cool, that works. But a review of what? I don't know, like a restaurant or something. So what's the relationship with a restaurant and a review?
Many reviews can be about the one restaurant.
Yep. Many reviews can be about one restaurant. Oh, snap. What's this shape?
Mm-hmm. Many to many.
Many to many. So now we say that people have a many to many relationship with restaurants. Ta-da. Other questions about relationships?
It's probably time to try to code them, huh?
Yeah! Beautiful. Any other questions before we get our hands dirty? All right, let's get dirty. So I would like you to follow along with the following. I'm going to make a new folder. I'm going to call it Relationships October. You can call yours whatever you want. Relationships October. So I've got nothing in this folder. Make sure that you got something set up. Get an empty folder going. Get caught up. I'm going to refill my water.
Take that.
Yeah, take that.
Take that.
You tell Alex.
It didn't work.
I believe take is for a file, not a directory, if I remember correctly.
To make and open
Take is for a
as a
directory.
file.
It's for a directory?
Yeah.
Yeah, connectors and CDs into it. That makes it fine.
Yeah, it says
All
take
right.
not found.
Okay, so got this empty folder. I want you to touch environment.rb. Ellen, I think you had the question at the beginning about how do we get these files to talk to each other? The thing you were missing was this file. This is the file that's going to like kind of coordinate and marshal and bring all of our other little one-off files together. And then this is the file that will actually run. All right, and then let's figure out what we're doing the relationship for. How about, let's do Hive and B. I like that one. So I also want you to make b.rb and hive.rb. If you're doing it just like I did, watch your capitals. They don't matter here. You can do lowercase if you want, but it is case sensitive.
Was there any reason that you did capitalize?
Yep, because that's where we're going to put classes, and classes by convention start with capital letters.
Tight.
All right, so open these up in your text editor. So we need a couple things in our environment file. First thing, we need to bring in pry. Like that. Then while we're at it, we throw that at the bottom too. Next, we want to bring in these Hive and B files too. So we're going to require ./hive and ./b. Your environment RB file should look like this. Then in your Hive file, you should say class Hive end. And then B should be the same thing, but with B's. B end. So what we have so far is this environment file that brings in Hive and B and runs a pry. This empty class for Hive, this empty class for B. All that should be like medium familiar to us already. Questions so far?
I'm a little. Go ahead.
Well, I just wanted to just double check the environment, make sure I'm requiring and putting the right slashes and dots in the right spot. Perfect. Thank you.
So
What's your
yeah,
question?
I'm a little confused with. I've seen require relative used, and do I need to be worrying about that yet or not really?
Not really. Just use require.
Okay.
Require relative does folders.
So, but require works for just files.
Correct.
Okay,
You got to
cool.
put the dot in the slash first.
But no .rb.
You don't. The only thing that you can require is an RB file, and so it just assumes that that's what you mean.
Okay.
Thanks.
All good.
Other questions so far? Cool. So, trying to make this as simple as I can. Let's say from the Hive side, we want to be able to add a B. So we make a method called add B. Any guesses what add B takes in as an argument?
A B object?
A B object. Cool. So this is where this gets a little weird. What we need to do is make a new B. Or let's say, we'll take the B, and then we want to set its hive to whatever hive called add B. So when we actually do this, it's going to end up looking like this. My hive is a new hive. I do my hive add B because it's an instance method. I also need a B to add in. So we're going to have Maya the B, and we'll add in Maya. So when we call myhive.addB and pass in Maya, it's going to set Maya's hive to my hive.
So that's the actual relationship formation right there.
Correct. The relationship has been made right here. Because Maya isn't a hive. We don't know anything about Maya. But we set a property called hive equal to a hive object. Now those two things have a relationship.
So is that kind of like the initialize thing?
Sort of. We haven't initialized anything.
Yeah, this is confusing because I don't know where you're getting the dot hive.
Nowhere. It doesn't exist yet.
Oh, okay.
Over on the B side, to do that, all right, so we need to be able to set a hive. How do I do that?
Initialize.
Oop, not necessarily. I just need, for instances of B, I need to be able to do hive equals. Because this method doesn't exist right now.
We'll make a hive instance method on the B class.
Yeah, I could do a hive equals instance method. Hive would be like, I want to read the hive. I could say hive equals. I could do something like that. Or isn't there a shorthand for this?
Attribute writer.
Yeah. Exact same thing. That is that. This will work.
So So in our initialize and stuff, we haven't created an attribute space or a hive. But when
there is
we
no
do,
initializer.
but when we do our writer, it will give that instance of B a new storage space for hive.
Correct. It doesn't need to be initialized with it.
Okay.
There are languages where that's not the case. Ruby is a little bit more flexible. Yeah, if you wanted to be super explicit about it, you could do something like def initialize and at hive equals nil. That'd be fine. Or you might want to initialize a B with a hive, in which case it'd be like that. That's fine too. But at a minimum, that's really all we need.
Can you kind of explain again what we're looking at right here with the b.hive equals self? What's self right in this instance?
So take a look at the example down here. So I made an instance of a hive. So my hive is an object of the hive class. Maya is an object of the B class. Neither of them have any other attributes. They're just instances of those classes. And I took one of the instances of hive. I called an instance method and passed in an instance of B. And I was able to call a method on that instance that was passed and set it equal to my hive. Because that's what called this add B method. That's self. So I set Maya.hive equal to my hive.
Is all that writing underneath the class? Like you would normally write that in the terminal, or?
Yeah, in the terminal or in the environment file. Yeah, I'm just trying to show you how these things would look once they're being used. These are blueprints. This is in action. Other questions? So let's say I want to do it from the other side. Because I said that like you can explore this relationship from both sides. So on the B side, you might have what? What would the method be called?
Add hive.
Sure. And what would it take in as an argument?
A hive.
Cool. And what happens on the hive? What's the body of this method?
Hive dot self equals B.
No, not hive.self.
I've got hive.
Hive dot B.
I'm in the B. This is Maya. I'm calling Maya.addHive and giving it a hive. And truth be told, I don't even need to do that because it's literally what this is. I can just do Maya.hive equals whatever I want. So I don't even need that. This is the smallest way we can do a one-to-many relationship.
But you have initialize in there somewhere, right?
Nope.
It's just not made yet. Okay.
Nope. Doesn't need one.
So if I understand correctly, there's an implicit hidden initialize in it.
Yep. It doesn't do anything.
Right. Yeah. It just allows the instance to run.
Correct.
If you wanted to specify, like, if it's a bee or a murder hornet or whatever, like you would have to initialize it?
Potentially, yeah. If I wanted to do it when I made it, that's what initialize is. So I could do something like def initialize name. And now when I make a new B, I need to specify that.
So that is only for attribute. If you need to put attributes to it.
Sorry, what was that?
Initialize is only if you need to put attributes to the object.
When you're making it. Because I
So
also
if you-
did that.
So it's
not
kind of the difference between, sorry, go ahead.
I could have done no initialize, but still made a writer for name. And then done something like Maya equals b.new, and then Maya.name equals Maya. Initialize is for things that you want to do when you make the object. Because you could make
Like
a
if
pretty
you're
good
mass
argument for this being kind of awkward and that being a lot more elegant. So cool, I agree. Should probably go there. More questions?
To be honest, I don't even know what questions to ask. This is a lot.
Pretty fucking wild, right?
Yeah.
Okay, so here's like a big takeaway from this. In Ruby, and in fact, in a lot of like programming sorts of situations, where are we keeping track of this relationship? Because we don't keep track of it in both places. We only keep track of it in one of them.
Environment.
Sorry, hang on just a sec. Hey guys, keep it down a little bit. So I'm sorry, where do we keep track of the relationship?
Environment.
Not in the environment.
In the one.
Instance?
In which instance?
The instance
In
we
this
create?
case, it's in the hive.
Ooh. We're storing it here. Which hive any particular bee is in, we're keeping track of it with this adder writer.
And the bee. Each individual bee.
Yeah, each individual bee knows its hive. The hives don't know their bees, not directly. They could get them through the bees.
This is exciting.
So in general, with these things, the many side of it stores the relationship. So a table knows its waiter. A bee knows its hive. A food knows its fridge. A baseball card knows its box. A review knows its person and its restaurant. The one side doesn't keep track of every little fucking thing that it has. The many side keeps track of who owns it. And at a minimum, this is the smallest possible example that you could make. Before we break, let's see it in action. So I move this over to the environment file. Try running this. Ruby environment RB. Oops, something I didn't like. Oh, I don't have the initializer anymore. I'm going to get rid of these. Okay, this is a whopping 3, 8. This is 12 lines of code. So if I say Maya is a new bee, and I say that Kyle's hive is a new hive, and then I call See, was it b dot add hive? Nope, hive dot add b. Nope. Oh, it's an instance thing. Maya dot. Nope, my hive dot add b Maya. Oops, did I not make my hive? Kyle's hive. Kyle's hive dot add b Maya. Hey, dope. Got added. If I make other bees, and I do Kyle's hive, add bee, other bee. Cool. Now note, I still can't get Kyle's list of bees. That's for another lesson. But that's how we store this relationship. This is how we relate to things. Ask me some questions.
Why isn't there a at symbol in add b method? Because aren't you storing that?
So what I'm saying is that it's really important in any kind of object-oriented programming of classes and objects and stuff. This hive doesn't actually know anything about how a bee works. All it knows is what methods we've made available to it. So it stores it in an instance variable, could be storing it in a local variable, could be storing it in a class variable. Hive doesn't give a shit. It just knows that, you know what, B has a method called hive, technically hive equals, and I can pass in myself to it. How it gets stored is here. And again, adder writer is just a shorthand for hive equals hive at hive equals hive. This and this are identical. And this reads really nice and easy, but it's technically the same thing as that.
So the method add b, would that be like that would be a class method?
Good guess. Instance method. Who can tell me why? Why is this an instance method, not a class method?
Because it's not calling self on the class level, or self to make it a class.
It isn't. That's not what makes it a class method versus an instance method, though.
Because the class the hive that you create is an object, is an instance. So when you do add b, it's to the object.
Yes, because I'm doing my hive.add b, not hive.add b. I'm not adding a b to the idea of a hive. I'm adding it to a specific hive. That's what makes it an instance method.
Is the equal sign being right next to b.hive, is that because it's like a writer, it's like a setter type of thing?
It's actually more interesting than that. It's because Ruby doesn't care about the space on that. That and that are the exact same thing.
Okay, because I knew we had to have it for setter, so it doesn't have anything to do with that.
So for this, I can't define a method like that. I have to write it like that. But I could use it like this or like this. Basically, it's like, and if that's confusing, don't worry too much about it.
Yeah.
But in Ruby, all there is objects and methods and stuff. So there's no equals. Equals is just another method. It's hive equals. It's literally just the name of the method. And again, that, it's just that. More questions?
There's a place where we could practice this stuff. Is that in an assessment somewhere, or?
Oh yeah. So
Okay.
like if you start in on the relationship stuff, there's lots of practices and stuff for this.
Where is it?
Also, cannot encourage you enough to go to the Blood Oath thing this
Blood Oath.
weekend, at least one of them. They'll dig a lot more into this. And if like your head is hurting right now, this is the hard thing. This is the hard part of mod 1. We spend almost the rest of the mod kind of just poking at this idea a little bit more. So I wouldn't be surprised if we're still talking about stuff kind of like this Thursday and Friday next week. Be patient with yourself. This one's heavy. But you'll also start to see it come together like probably mid next week. Why we had to do all the enumerable stuff? Because like I mentioned, I can't get all of my hive's bees right now. To do that, I would need to map and select and unique and
I really appreciate.
start coming together.
Yeah, I really appreciate you saying that too, because my head was like, whoa.
Like a whirlwind like this.
Yeah, awesome. That
It's heavy.
that was cool.
Awesome. Go practice. I'll see you at 4.
Thanks,
Thanks,
guys.
Kyle.
And then